Okay, Assalamualaikum and good morning. Okay, LU2, application of differentiation. Question 5, 1 to 4 Bani. Okay, question 5, find the relative maximum and minimum point using the first derivative test. Okay, first check the method. Method here using the first derivative test. Okay, function fx here equals to the 4x cubed minus 3x squared plus 2. And first you find the first derivative of the cubic function. 12x squared minus 6x. Okay, and you let the first derivative here equal to 0 and find the value of x. X here equal to 0 and equals to the 1 over 2. Yeah, and the first point x here 0 and y here equals to, we check answer. Okay, so you substitute the 0 and the 1 over 2 into the function, and the first point here at the 0, 2, and the second point at the 1 over 2, 7 over 4. Yeah, and method using the first derivative test determine the relative extremum point. So table here, the value of x, first derivative, and the shape of tangent. Yeah, and in conclusion, maximum at the 0, 2, and the minimum point here at the 1 over 2, 7 over 4. Okay, check answer. Yeah. Question 5, kalau yang pakai the second derivative test, you all perbetulkan. Yeah. Jadi question 5 ini method dia kita dah tetapkan. Jadi you pakai first derivative test sahaja. Yeah. Okay, question 6. Okay, question 6. Show that the stationary point maximum using the second derivative test. Okay, sekali lagi. So method here using the second derivative. Method ni pastikan betul lah. Jangan pakai method yang salah. Okay, question 6. Okay, first find the first derivative of the function. Fx here equals to the ln x squared over x. And u here 2 ln x and v here equals to x. Okay, check answer. Yeah. First derivative, 2 minus 2 ln x over x squared. And then you let the first derivative here equal to 0. And the value of x or the stationary point here equals to the e. Yeah. So here the base of the ln function. Ni kita check balik. This one from the LU2. Base of ln here equals to the 2.718. Yeah. And the value of x here equals to the 2.718. So answer you here, x equals to e, or answer you x equals to the 2.718. Yeah, final answer ni up to you lah. Yeah. And then you substitute into the function and find the value of y. Y here equals to the 0.736. Ini sebagai jawapan. Okay. And answer 2.718 and 0.736. Answer you here at least 3 decimal places. Okay. Okay, and then using the second derivative test, determine the relative extremum point. So the second derivative of the function, okay, you'll check. So u here equals to the 2 minus 2 ln x. V here equals to the x squared. So you differentiate. Second derivative here equals to the 4 ln x minus 6 over s cubed. Okay, check jawapan. Okay, and using the second derivative test determines the relative maximum point. So the relative maximum point here, you substitute the value into the second derivative. Okay, and the second derivative here equals to the negative 2 over e cube, or the sign of the second derivative here negative. Okay, so conclusion you here, the relative maximum point. Dia terbalik negative sign relative maximum, positive sign the relative minimum point. Okay, and conclusion, the stationary point here with the relative maximum point. Okay, settle question 6. Yeah. Question 5 and question 6, pastikan method you all betul lah. Okay. Kalau you pakai method yang salah, betulkan balik. Okay. Question 7. Okay, question 7. Question A and B show that the volumes of the cylinder equals to the 44x minus 22 over 7x square minus 22 over 7 x cube. Okay, first method. Method here in terms of x. Method ini pastikan betul lah, jangan pakai method yang salah. Okay, so you write down the volume of the cylinder in terms of x. Okay, so the total surface of the cylinder 2 pi r square plus 2 pi r time hash. The basic formula of the cylinder, cone, cube dan sebagainya, you all kena hafal lah. Itu the basic one. Yeah. So you first here you replace the radius with the x. So 2 pi x square plus 2 pi x time hash. So this area in terms of x. Okay, and write down the hash here in terms of x at the end minus 2 pi x square over 2 pi x. Okay, and substitute into the volume of the cylinder. You substitute here pi r square time hash, and then hash here minus 1 over 2 minus 1 over 2. This one you punya overlaps. So the value of hash here equals to the hash minus 1. Okay. So at the end minus 2 pi x square minus 1 over 2 pi x. And last here the volume of the cylinder equals to the 44x minus 22 over 7 x square minus 22 over 7 x cube. Okay, dapat jawapan. Yeah. Okay, settle question B, question A and question B. Okay, question B, find the maximum volume of the cylinder. Yeah. Okay, first find the first derivative, differentiate in terms of x, dv over dx here equals to the 44 minus 44 over 7x minus 66 over 7 x squared. And you let the first derivative here equal to 0 and find the value of x. X here equals to the negative 1 plus minus 43 over 3, or answer you here in a decimal point. Lagi mudah pakai decimal point. Okay. So here saya letakkan jawapan 1.8525. At least 3 decimal places. Yeah. Okay. And then using the second derivative test determines the relative maximum and the relative minimum point. So you substitute the value into the second derivative. Okay, this one you check. Negative sign, the maximum. Positive here, the minimum point. Okay. Or the second method, ini saya tunjuk. Ini this one you boleh pilih. Second method using the first derivative test. Okay, so the second method using the first derivative test. So the tables here, the value of x, dv over dx, and last here shape of tangent. Ya, kebiasaan dia kalau you gunakan first derivative dia lagi mudah dan lagi cepat. Ya, saya galakkan you pakai first derivative. Ya, and then last find the maximum volume of cylinder. Answer you here equals to the 50.7443 centimeter cube. Okay, settle. Okay, question X and okay, question X. Quadratic function y here equals to the negative x power 4 minus 4x squared minus 3. So first step here, find the stationary point of the function. This one is step 1. Turning point, ni saya tunjukkan balik. This one, stationary point, turning point, and the local extrema. Tiga benda ni kalau you all jumpa, dia benda sama saja sebenarnya. Stationary point, turning point, and the local extrema. Dia benda sama, tapi nama dia lain. Yeah? And the stationary point of the function exists when the first derivative here equal to 0. So negative 4x cubed minus 8x equal to 0. And the first point here, x here equal to 0. And the second value, x here equals to the third negative. So this one answer you undefined. Yeah. And substitute into the function. And the y here equals to the negative 3. So the first stationary point here at the 0, negative 3. Okay, settle. First step. Okay, step 2. Di sini ya. Okay, step 2 using the first derivative or the second derivative test determines the extremum point. So x here equal to the 0. This one the table of the first derivative. And the shape of tangent here increase, horizontal and decrease. So conclusion you the relative maximum at the 0, negative 3. Yeah. This one step 2. And step 3, find the inflection point. Okay. The second derivative here equals to the negative 12x squared minus 8. And you let the second derivative here equal to 0. So the inflection point here equals to the third negative. So this one, inflection point D and E does not exist. Yeah. Okay. And step 4, table of concavity, you all check. So graph here concave downward, ini check nanti ya. Okay. And last year, you check the graph. Step 5 you punya intercept. Intercept ni saya bagi jawapan saja. Intercept ni calculator cukup. Okay, so step 5, intercept of the function. Y-intercept here at the 0, negative 3. X-intercept here undefined. And last you sketch the graph of the quadratic function. Yeah. The maximum value here you label at the 0, negative 3. Inflection point does not exist and graph here concave downwards. Okay, settle. Yeah. Quadratic function, you punya step dia ada 6 step. Ia sama dengan cubic. Step 1 to the step 6. Better you all buat step by step. Yeah. Okay, settle quadratic function and the rational function. Okay, rational function, sketch the graph of the y equals to the x squared minus 1 over x squared minus 4. Okay, first step, find the vertical asymptote of the rational function. This one you punya step 1. And step 2 here, find the horizontal asymptote. Sama macam dalam video. Okay. Okay, check dulu. Okay, first find the vertical asymptote of the rational function method using the infinite limit. So you let the denominator of the function x squared minus 4 equal to 0, and the value of x here equals to the plus minus 2, yeah? So the first value of x here positive 2, and the second value here equals to the negative 2, yeah? Here from the right of the rational function, here from the left, and here from the left of the function. You boleh check ya, ini calculator saja. And conclusion you here x equals 2 and x equals to the negative 2 is a vertical asymptote of the rational function. Okay, settle step 1. Yeah. And step 2, horizontal asymptote. Method using the limits at infinity. Limit as x approaches positive infinity of x squared minus 1 over x squared minus 4, and the highest degree of the denominator here equals to the x squared ini, yeah. And this function divided by x squared, and answer you here equals to the positive 1, yeah. Okay, settle, and y equals 1 is the horizontal asymptote. Ini you punya conclusion. Okay. And step 3, find the stationary point of the function. Kita ke atas. Okay, daripada terbalik. Okay, check. Okay, step 3, find the stationary point of the rational function. First derivative, dy over dx here equals to the negative 6x over x squared minus 4 power of 2. Okay, this one using the quotient rules. And you let the first derivative here equal to 0, and the value of x here equal to 0, and substitute into the rational function. Y here equals to the 1 over 4. So stationary point here at the 0, 1 over 4. Okay, check answer. Step 3. And using the first derivative test, determine the relative extremum point. So you substitute this one, the value of x, and here the first sign of the first derivative. This one you can dapat 0. Maybe here from the left, here is equals to the 1 over 2. Okay. And here from the left here, maybe you put the negative 1 over 2, the nearest value. Yeah. And here the relative maximum at the 0, 1 over 4. Yeah. And last step 4 and 5, intercept and sketch the graph of the rational function. Impression point ini tak perlulah. Kebiasaan dia does not exist. You check tak check pun sama saja. Okay, check answer. Here the step 4 saya bagi jawapan. Intercepts. Yang mudah ni saya bagi jawapan saja. And here the step 5, dia punya graphs. Okay, so step 4, intercept of the function. Y-intercept here 0, 1 over 4, and x-intercept of the function here undefined. This one you all check calculator. And last here you sketch the graph of the rational function. So you label the vertical asymptote plus minus 2, horizontal asymptote here, y here equals to 1. Yeah. And you label the relative maximum at the 0, 1 over 4. Okay, settle. And step 6, domain in the range of the rational function. Domain of the rational function is all the real numbers except the vertical asymptote. Negative infinity, negative 2 unions, negative 2, 2 unions 2 to the positive infinity. Yeah. And the range of the function, negative infinity 1 over 4 using the semi-open bracket. Unions 1 to the positive infinity. Range of the function bottom ups, yeah. And between 1 over 4 and y equals to 1, graph of the rational function here D and E does not exist. Okay. Jadi between ini memang tak ada benda, dia kosong sahaja, ya. Okay, and last step 7, behavior of the function. Okay, behavior of the function, x here approaches to the positive infinity, and y here approaches 1 at the infinity. So here graph of the rational function here above the horizontal. So here you put the positive sign, yeah. And second, x here approaches negative infinity, and y here approaches 1 at infinity. Ini pun sama. Graph here above horizontal, and here you put the positive sign. Mudah saja. Kalau you punya graph itu below horizontal, this one you replace with the negative sign. Konsep mudah saja, ya. Okay, settle. Question 9, rational function. Rational function ni paling panjang dia punya step. Dia ada 7 step. Step 1 to the step 7, ya. And question 10. Okay, question 10, find the gradient of tangent at the point 5, negative 1. Ini saya jawapan cukup. Ini mudah saja. Question A, saya bagi jawapan. So you find the first derivative, dx over dt, check answer. And here dy over dt, negative 4t. And the parametric equation, dy over dt times dt over dx. Okay. And dy over dx here equals to the negative 40 over 2 plus 60. And the value of t here equals to 1. And substitute into the first derivative. And the first derivative here equals to the negative 1 over 2. So here the mt, or the gradient of tangent, equals to the negative 1 over 2. Okay, mudah saja. Ya. Okay, question A. Question A ni sangat tak ada masalah, ramai boleh buat. Question B. Question B dah ada sikit check. Question B, the rate of change. Rate of change ni complicated sikit. Saya tunjukkan you punya keywords. Okay, check . Okay, first here, method. You find the rate of the decrease. Yeah, you check . Okay, first you check the rate of decrease method here in terms of the height. Okay, you will check. And the second, given the volumes in terms of the time dV over dt equals to the 12 centimeter cube per second. And the radius here equals to the 8 centimeter. Yeah. Okay, you punya method pastikan betul lah. Okay, yang ini. Kalau method you pakai method salah, memang confirm you punya jawapan tu salah nanti. Yeah. So method here in terms of the height. Okay, so first write down the parametric equation. Saya tunjukkan per step. So dV over dt. Okay, so dV over dt equals to the dV over d hash times d hash over dt. So this parametric equation here in terms of the height. And step 2, write down the radius here in terms of the height. So you compare the radius and the height here, compare with the radius and the height, 8 and 16, and cross multiply, yeah? And the height here, radius equals to the hash 1 over 2 times hash. And here in terms of the height. Kita pakai satu term sahaja, yeah? Okay, step 2, and substitute into the volumes 1 over 3 pi r square time hash, and the volume here 1 over 12 pi hash cube, and here in terms of the height. Okay, and here you punya step 3. Okay, kita buat step by step. Okay, and find the dV over the hash 1 over 4 pi hash square. Okay, and the rate of change of the rate of decrease dV over dt equals to the negative 12 centimeter cube per second. This one you punya step 4. Okay, and last year step 5, find the d hash over dt. Okay, check jawapan. Okay, and the height of the equals to the 10 centimeter, so you substitute. And the answer here, d hash over dt equals to the negative 12 over 25 pi centimeter per second. Yeah. So the final answer, you put the negative sign. This one you punya rate of the decrease. Yeah. Kalau you letakkan positive sign, jadi you punya final answer tu salah. Okay. This one you letakkan rate of decrease ataupun saya tunjukkan. Okay. Kebiasaan dia kalau ni mudah, dia check dia punya term sahaja. For example, this one kalau water leaking pun sama. Kalau water leaking, ini soalan dalam slide. You punya final answer pun sama. You letakkan negatif. Ya. Kalau you tak nak letak negatif, you tulis panjang. Rate of decrease ini pun boleh. Kalau tulis panjang, tak perlu letak negatif. Rate of decrease equals to the 12 over 25 pi centimeter per second. Ini pun boleh juga, tak ada masalah. Ya. Okay, settle. Rate of change and question 1 to 4. Yang mudah ni sebagai jawapan sahaja. Okay, check answer. Okay, check answer. Okay, question 2, true or false, 1 marks. And the reason here, 1 marks. Soalan ni tak banyak. Soalan ni paling banyak pun 2 markas saja. Soalan macam ini jangan tulis panjang sangat. Satu line cukup. Jangan tulis panjang sangat. Markah dia tak banyak pun. Soalan yang solution tadi, you all tulis panjang. Markah dia besar. Ya. Okay, so question 2, CLO1, 2 marks. Okay. And question 3. Okay, question 3, check answer. Ini mudah saja. Find the equation of tangent at the point 50. Okay, cek jawapan. Check solution. Okay, question 3. You check the x dx over dt 2 plus 60 dy over dt equals to the negative 2t. And the parametric equation here, dy over dx equal to the dy over dt times dt over dx. And the first derivative, negative t over 1 plus 3t. And then you let it equal to 0 and t here equals to the plus minus 1. And answer you, t here equals to 1. Ini you all check calculator. Yeah. And the gradient of tangent, you substitute this value into the first derivative. And the first derivative here equals to the negative 1 over 4. Ini cek jawapan. Yeah. And then negative 1 over 4. And the equation of tangent y minus yt equals to the gradient of tangent times x minus xt. And answer you here 4y minus x plus 5. Okay. Here answer in terms of x plus b. Or answer you in a general form pun boleh, tak ada masalah. Final answer ni tak ada masalah. 4y plus x minus 5 and equal to 0. Ini pun betul. Ini pun betul. Okay. Okay, settle equation of tension and question 4. Okay, question 4. Show the equation of normals equals to the 4y plus 32x equals to the 297a. Okay. So first here, find the first derivative. So you punya first derivative, y raised to the power of the 3 over 2 over x power of 3 over 2. Yeah. And the gradient of tension, dy over dx. So you substitute this point into the first derivative. Okay. And dy over dx here, or mt, equals to the 1 over at. Okay. And the gradient of the normals, mt, mn, negative 1. And mn here equals to the negative at. Okay, check answer. And then last, find the equation of normals. Okay, dapat jawapan. Okay, equation of tangent, equation of normals, saya ingat tak ada masalah. Ramai boleh buat. Itu yang paling mudah untuk LU2 ni. Equation of tangent, equation of normal, itu yang paling mudah. Mudah-mudah sahaja. Ya. Okay, saya buka soalan. Kalau ada soalan, you all boleh type dalam chat meeting. Saya cek dulu you punya attendance. Berapa ramai yang hadir hari ni. Cek dulu. 35. Okey lah, boleh lah ni. Okey, kalau ada soalan, boleh check, type dalam chat meeting. Okay. Okay, ada soalan, saya cek. Okay, question daripada Nurhanis dan question daripada Nurhanis. Macam mana nak tahu stationary point using the first derivative test or using the second derivative test? Okay, soalannya bagus. Soalan bagus. Macam mana kita nak tahu kita punya method tu sama ada using the first derivative ataupun second derivative test? Ya, ini saya tunjukkan terus. Ini nanti kalau dalam exam, you all baca dahulu soalan. Kalau tak baca soalan, you buat terus saja, saya takut you punya method salah nanti. Mudah saja. You check soalan. For example, this one, question 5. Find the relative maximum minimum point using the first derivative test. Biasa kita tetapkan. Ya. Ataupun kalau soalan 5 ni saya ubah, find the relative maximum minimum point using the second derivative test. Itu baca soalan dahulu, ya. Kalau soalan dia tak tetapkan, for example, find the relative maximum point and then full stop. Itu maksud dia, you boleh pilih sama ada first derivative ataupun second derivative test, ya. Okey, satu lagi contoh saya tunjukkan, ini pun sama. Question 6, you show the stationary point using the second derivative test. Kita dah tetapkan dia punya method. Jadi you follow sahaja, ya. Kalau soalan ni saya bagi contoh soalan kat sini, you show the stationary point of the function and then full stop. Itu sahaja. Maksudnya you boleh pilih mana-mana method sama ada first derivative ataupun second derivative test. Yang penting you all baca soalan, ya. Okay, question 2. Check. Question 2C, can I put the reason true because the domain of the function negative infinity to the positive infinity? Sekejap, saya cek soalan. Okay, you punya reason tu you bakalan. Reason domain of the function negative infinity to the positive infinity. Question dia is domain is all the real numbers. Okay lah, boleh, tak ada masalah. Dia punya reason ini ikut logik saja. Kalau you fikirkan dia punya reason tu logik, you masukkan saja, tak ada masalah. Sebab dia punya reason ini markah dia tak banyak pun, satu markah saja. Okay? Dan pastikan you punya reason tu tulis satu line saja. Saya tak nak baca panjang. Okay? Kalau solution panjang tu saya boleh baca. Yang tulisan-tulisan yang reason tu satu line cukup. Ya? Okay, ada lagi soalan untuk LU2? Okay, ada lagi. Saya tunggu. Okey, tak ada lagi soalan. Saya ingat kalau tak ada soalan, saya ingat itu sahaja untuk hari ini. Dan jangan lupa minggu depan you all ada online quiz untuk LU1 and LU2. Okey? Okey, kelas itu sahaja. Dan Assalamualaikum warahmatullahi wabarakatuh. Okey, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.